All right, diving in today, folks. We're going deep on intentional logic.
Oh, a fascinating area.
Yeah, it really gets at the heart of meaning, what we mean when we use words versus just what they point to in the world.
The relationship between meaning and designation. Exactly. And
Yeah.
how those two can sometimes come apart in really intriguing ways. For philosophers, this is fundamental stuff.
Exactly. And, it all started really with Frege and his big insight that words, terms, they have these two sides.
Right. There's the reference, like the actual thing in the world a word picks out. That's its extension. And then there's the sense, the way that thing is presented to us, the concept we have of it.
So, classic example, morning star, evening star.
Ah, yes, the Venus puzzle. Same planet, different names.
Exactly. We know it's the same planet, Venus, right? Same reference, same extension.
Precisely.
But here's the thing that gets philosophers going, saying the morning star is the evening star. That's a discovery. It tells us something new. But saying the morning star is the morning star, well, that's just duh.
It's a tautology. No new information there. And yet, both statements are about the same object, Venus.
So that's what we're digging into. How can two descriptions pick out the same thing but have this huge difference in, cognitive significance?
It all comes down to the difference in sense, in intention, as intentional logic calls it. That's where the real meaning is.
Right, right. So in this deep dive, we're going to trace how philosophers have wrestled with this, especially when it comes to stuff like knowledge and belief. Those contexts where what we mean is more important than just the thing we're talking about.
Absolutely. These are called intentional contexts in the jargon. Think about statements like, it is known that, or she believes that.
Right, and you can't just swap out words that refer to the same thing in those contexts and always keep the truth the same.
Exactly. Someone knows that the morning star is bright. Doesn't mean they know that Venus is bright, even though it's the same thing. That difference in sense matters.
Totally. So we're going to unpack all that, the attempts to formalize this notion of intentionality, how it plays into our understanding of knowledge, logic, even math and names.
And we'll see how this impacts some pretty big philosophical puzzles any philosopher will find engaging.
Okay, so to kick things off, we got to start with Frege. He's the OG here, right? Laid the groundwork.
Oh, absolutely. Frege's 1892 paper, it's like ground zero for modern discussions on this.
So what was he grappling with that led him to this, sense and reference stuff?
He was initially really hung up on equality. What does it mean for two things to be equal? At first, he thought maybe it's a relation between the signs we use, not the objects themselves.
Okay, I can see where he's coming from. AA, that's just kind of obvious.
Yeah.
But A, where A and B happen to refer to the same thing, that can be a big discovery.
Precisely. If equality were just about the objects being the same, we couldn't explain that difference.
Yeah, right. But then he realized even focusing on signs isn't enough. Because the link between a sign and what it refers to can be pretty arbitrary, right?
Exactly. So he needed something more. And that's where he hits on this crucial distinction between sense Sinn in German and reference Bedeutung.
All right, so break it down for us. What's the difference?
Okay, so a sense of a sign is like its mode of presentation. Think of it as the way an object is presented to us conceptually, the way we grasp it.
Gotcha. And the reference is just the actual object out there in the world.
Exactly. So back to our morning star, evening star example. They have the same reference, Venus, but different senses. Two different ways of conceiving of the same planet.
One's all about how it looks in the morning. The other's about the evening. Different paths to the same destination.
Right. And Frege, she even toyed with this idea of a subjective idea associated with a sign, but ultimately he wanted sense and reference to be objective, like they exist out there, independent of anyone's particular thoughts.
Okay, so how does this whole sense and reference thing help with those tricky intentional contexts we were talking about? The knowing that, believing that stuff, which is so important for philosophers.
Yeah. Well, Frege said, in those contexts, it's the sense of the words that matters most, not just the reference.
Because, I could know something about the morning star without knowing it about Venus if I don't realize they're the same thing.
Exactly. The different senses can make a difference to the truth of the whole statement. And Frege, he went even further, applying this to whole sentences too. He said the sense of a sentence is the proposition it expresses, and its reference is its truth value, true or false.
Whoa, so two sentences that are logically equivalent, they have the same truth value, same reference, but they could still express different propositions, have different senses.
Exactly. Think about a complex mathematical theorem and a simple axiom it comes from. Both true, but the theorem's expressing a way more complex idea, a different sense, than the axiom.
So Frege, he kind of set the stage, defined the terms, pointed out the problems, but he didn't really build a complete formal system to handle all this, right?
Right, he was more about laying out the philosophical groundwork. The task of building a formal logic of intentions, well, that fell to others, folks like Alonzo Church.
Okay, so Church enters the picture. How did he try to take Frege's ideas and make them into a rigorous logical system?
Church, in 1951, he really went for it. He tried to create a logic where terms have both senses and denotations, treated as different logical types, almost like different categories of things. But, oh boy, things got complicated fast.
Why is that? Too many senses to keep track of.
Well, part of it was because he was working with type theory, that system Russell developed to avoid those nasty paradoxes Frege ran into.
Ah, right. Russell's paradox, the whole set of all sets that don't contain themselves thing. Classic philosophical headache.
Exactly.
Hmm.
Frege's system didn't have these types, these categories to keep things organized, and that led to contradictions. So Church, he incorporated type theory to keep things consistent, which made the logic more complex.
So type theory is like a set of rules to avoid logical explosions. Gotcha. So what were Church's main ideas within this type theory framework?
Well, he used the term concept to talk about the sense of a name, but he left it kind of open what concepts are exactly. Like maybe they're not even tied to language, and there could be a ton of them, an uncountable infinity even.
Uncountable infinity. Like more than all the natural numbers? That's a lot of concept.
Right. And then he introduced different logical types for objects and for concepts of those objects. So there'd be a type for, say, truth values and a separate type for concepts of truth values, basically mirroring the hierarchy of objects with a hierarchy of their concepts.
Like a parallel universe of meanings alongside the world of stuff. Pretty neat.
And to simplify things a bit, he assumed that concepts of functions are themselves functions, just operating at a higher level in this type hierarchy.
So a way to handle concepts uniformly across different types of things. Clever. But how did Church deal with the problem of, like, when do two terms have the same sense? That seems pretty crucial for a logic of meaning.
Yeah, that was a big one. He explored a bunch of options, but a core idea for him was that the sense of a term shouldn't change if you just rename bound variables or do some basic lambda calculus stuff. Beyond that, he considered a whole spectrum of possibilities. Like, on one end, you could have senses be super fine-grained, different whenever possible, and on the other, you could say two terms have the same sense only if it's logically provable that they're equal.
So he was kind of mapping out the territory, showing us the different ways we can build this logic of sense.
Exactly. His work was more like a research program than a finished system. He was opening up the field for others to explore.
And one of those explorers was Rudolf Carnap. He took things in a different direction, right? More focused on semantics.
Yeah, Carnap was all about giving a precise meaning to intentions within a formal system. He was influenced by Frege, of course,
Yeah.
and maybe indirectly by Wittgenstein's Tractatus, with its focus on states of affairs.
Ah, the Tractatus. Classic Wittgenstein. The world is everything. That is the case.
Right. And Carnap took this idea and developed it into these things called state descriptions. Think of them as complete descriptions of a possible way the world could be, expressed in a formal language,
Okay, like a list of all the facts in that possible world.
essentially. And each state description determines whether every sentence in the language is true or false in that possible world.
And this led him to his idea of truth, logical truth, or necessary truth.
Yes, he initially defined it informally as truth that follows just from the rules of the language, not from facts about the world. But later he made it more precise, saying an L-truth is true in every state description.
Ah, so that's like our modern idea of a necessary truth, something that's true in every possible world.
Exactly. It's a clear forerunner of possible world semantics, which is huge in philosophy today.
Okay, so how did Carnap use these state descriptions to define intentions? Like, what's the intention of a predicate, for example?
For predicates, like human, he said the intension is a function that tells you what the extension is, the set of things the predicate applies to in each state description.
Okay, so like human and featherless biped might pick out the same things in the actual world, but in some other possible world, they could be different.
Exactly. So they have different intentions, even if their extensions happen to line up in our world.
Because their extensions could come apart in some other possible world.
Mm-hmm.
Makes sense. What about individual expressions like names?
For names, he said the extension in a state description is just the individual the name refers to. And the intension, which he called an individual concept, is a function that picks out the referent of that name in every state description.
So, like, Scott and the author of Waverly might refer to the same guy in our world, but they have different intentions.
Right. Because you could imagine a world where Scott exists but didn't write Waverly, or where someone else wrote it.
So the intention captures all those possible ways the reference could have turned out. Pretty cool. Carnap really gave us the semantic machinery to make sense of intentions, which Frege kind of left hanging. But were there still, like, open questions or different approaches out there?
Oh, absolutely. While Carnap was mostly focused on semantics, there was Ruth Barkin Marcus, who was working on extending formal modal logics to include quantifiers and identity. She was really trying to address Quine's famous objections to modal logic.
Ah, Quine. Always a tough critic. He
All
had
right.
issues with, like, quantifying into modal contexts, right? Something about substitutivity breaking down.
Exactly. He thought modal contexts messed things up for classical logic, especially when it comes to identity and existential generalization. But Marcus, starting in the 1940s, she developed these systems like S2 and S4, showing you can have quantifiers and equality in modal logic without everything falling apart.
And she came up with the Barkin formula, right? That thing about the necessity of existence and the existence of necessity.
Yeah, that was in her 1946 paper. It became even more important later on with the rise of possible world semantics, but it was a key step in formalizing quantified modal logic.
And she also tackled the problem of abstraction and identity in modal logic, which are huge for philosophers thinking about essence and modality.
Oh yeah, big time. She extended her systems to include abstraction principles and explored two different versions of identity, one based on having the exact same properties and one based on necessarily having the same properties. And she proved they're actually equivalent in S2 and necessarily equivalent in S4.
So she was showing how you can reason about identity in these more complex modal settings. What about the morning star, evening star puzzle? How did she deal with that, given her focus on mobile logic?
She had a different take on it. She thought those puzzles come from treating names like they're hidden descriptions. Like, morning star is secretly just a description, and so is evening star. But Marcus, she said, no, names are more like tags. They pick out an object, but they don't have their own Phrygian sense.
Okay, so for her, once a name is stuck on an object, that's it. The identity's fixed, it's necessary.
Right, so the morning star is necessarily the evening star, but we just didn't know it at first because we happen to give the same planet two different tags.
Interesting. So she kind of sidesteps the whole sense and reference thing by saying names are just these bare designators, rigid from the get-go.
Exactly. And her work was really important in showing that you can have these formal modal systems that handle quantifiers and identity in a consistent way,
Hmm.
even though the full-blown possible world semantics for them came a bit later.
Right, and that semantic development was pushed forward by a whole bunch of folks. Montague, Tichy, Bresson, Galin, names that'll make any philosopher of language's ears perk up.
Oh, yeah. They were all working on this stuff largely independently, and they all embraced possible world semantics, building on Carnap's ideas, but using possible worlds instead of state descriptions. And they all agreed that intensions are functions from possible worlds to extensions.
Didn't Bresson have this thing about physics?
He did. He was really into the foundations of physics and realized that you need a strong modal language to capture all the counterfactual reasoning physicists do. Like, what would happen if the laws of physics were different? That kind of thing. So he developed these really intricate modal systems with types and everything, including ways to handle numbers and physical quantities.
And Montague, of course, was all about natural language, trying to give a formal account of how we speak.
Yeah, his big project was to build a formal semantics for natural language, and intentions played a huge role in that. Montague focused more on semantics, but Galen later came along and gave an axiomatic basis for a similar system.
And what about Tichy? He's not as well known, but I hear he had some cool ideas, too.
Oh, definitely. Tichy's system was a lot like Montague's, but he added some neat twists. Like he made intentions depend on time as well as possible worlds. Because, meanings can change over time.
Words taking on new senses. That's definitely a thing.
Right. And he also introduced this idea of constructions, which are different from both intensions and extensions, like 1 plus 4 and 2 plus 3. They both refer to 5, so it's the same extension. And their intentions, as functions, might even be the same, but Tichy said they represent different ways of getting to 5, different procedures.
Ah, so it's like the intention is the map, but the construction is the route you take.
Exactly. So that starts to get at this idea that meaning might be about more than just like what a term refers to in different possible worlds, it might also involve the process of determining that reference.
Which is super interesting for philosophers thinking about the link between meaning and computation.
Absolutely. Now, to really get a handle on some of these basic concepts without getting bogged down in all the technical stuff of higher order logic, we could look at a simpler system called FOIL, first order intentional logic.
Okay, FOIL. Sounds less intimidating. What's the gist of this system? How does it help us understand intentionality?
FOIL, it mainly deals with intentional predicates and individual concepts,
Yeah.
which are represented by constants and variables that can pick out different things in different possible worlds. And the models for this logic use functions from states, those possible worlds, to objects as the meanings of those intentional things.
So it's still got that core idea of intentions as functions.
Yeah, it's there.
Yeah.
And AFIL can even handle the distinction between de re and de dicto modality, which is a big deal in philosophy.
Right, de re de dicto. Those always trip me up. Can you remind us what those are all about?
Okay, so basically de re is about a property holding of a specific object. Like in every possible world, that object has that property. De dicto is more about the proposition itself being necessary.
So de re is more about an object's like essential properties, and de dicto is about the truth of a statement in all possible worlds.
Yeah, that's a good way to think about it. And FOIL uses lambda abstraction to make this distinction formally. So you can have something like lambda x diamond px for de re, where F is an intention picking out an object and P is a predicate.
Lots of symbols. But the point is, the lambda thing lets you specify whether the modal operator, the diamond in this case, applies to the object itself or to the whole proposition.
Exactly. It's a scope marker, basically. And the formal semantics of lambda abstraction in FOIL makes it all super precise. Like lambda x is true at a state V if and only if x is true at a state W that's just like V, except that x gets assigned whatever F refers to in V.
Okay, my head's starting to spin a bit. Can we have like a concrete example to illustrate this?
Sure. Imagine F is the intention of the tallest person and G is the intention of the oldest person. Now, the statement is necessarily the case that the tallest person is the oldest person. That could have two readings.
De re and de dicto.
Right. The de dicto reading means in every possible world, whoever is the tallest is also the oldest. Probably not true. But the de reading box says the specific individuals who happen to be the tallest and the oldest in our world are identical in every world.
Ah, so that could be true if those two people are actually the same person and their identity is necessary.
Exactly. And that shows how even this simpler FOIL system can handle some pretty subtle distinctions. Now, we talked about rigid designators earlier. How does rigidity play out in FOIL, and what kind of philosophical trouble does it cause?
Yeah, rigid designators. So those are terms that refer to the same thing in every possible world, right?
That's it. And in FOIL, if a term is rigid, the de re and de dicto readings kind of collapse into each other. They become logically equivalent.
Because if the thing you're referring to is always the same, it doesn't matter whether you attach the modal operator to the object or the whole proposition.
Right. But this rigidity thing, it leads to some tricky puzzles for philosophers, especially when it comes to math and proper names.
Yeah, like how can I not know that 1 plus 4 equals 2 plus 3 if both sides always refer to 5 no matter what?
Right. That's a big problem for any theory that says mathematical meaning is just about reference. If the intention of 1 plus 4 is just this rigid function that spits out 5, and same for 2 plus 3, then everyone should automatically know they're equal.
But I don't just know all mathematical truths instantly. I have to work them out sometimes.
Exactly. So some philosophers have suggested that maybe the intention of a mathematical term is more about its computational content, like the algorithm you use to calculate it.
So the intention of 1 plus 4 is the process of adding 1 and 4, which is different from the process of adding 2 and 3, even though they both give you 5.
Precisely. The map's the same, but the routes are different. But even this idea has problems. Like, I can know 1 plus 4 refers to some number without knowing which number until I actually do the addition.
Right, so maybe there's something about actually carrying out the procedure that's crucial for mathematical knowledge.
And this ties into the whole problem of logical omniscience. The idea that if you know some stuff, you automatically know all the logical consequences, no matter how complicated, which seems pretty unrealistic.
Yeah, no one's walking around knowing every single theorem that follows from the axioms of math.
Exactly. So to deal with that, there are things like awareness logics, which say you might only be aware of some of the logical truths you know. And then there are justification logics, which are even more complex, where you actually keep track of the reasons you believe things.
So knowing something in math isn't just about knowing the truth value, it's about having the proof, the justification.
Right on. Now, switching gears to proper names, rigidity causes problems there too. Like, how can the fact that Hesperus and Phosphorus both refer to Venus be a necessary truth if we had to, like, do astronomy to figure it out?
Right, Kripke's famous example. We had to observe the morning star and the evening star to realize they were the same planet.
Yeah, that one's a classic. The standard view now is that proper names are rigid designators. Once Hesperus gets hooked onto Venus, that's it. It refers to Venus in every possible world where Venus exists, save for Phosphorus.
So Hesperus's phosphorus is a necessary truth, but it wasn't obvious at first. Kind of a paradox.
It is, so how do you square that with the fact that we had to discover it?
Yeah, why wasn't it just obvious from the meaning of the names?
Kripke said, look, rigidity is about how names work in metaphysical models, the models that represent how things really are. But it doesn't necessarily apply to epistemic models, models of what we know or believe.
So metaphysically, the identity is necessary, but epistemically, we might not know it.
Right. We could have been in the same situation, seeing two bright objects, even if they weren't the same planet. And we'd still use the names Hesperus and Phosphorus.
So a necessary truth doesn't always mean we know it right away. There's a difference between something being true in every possible world and us being able to figure it out just by thinking.
Exactly. And that's a problem for these simple intention as function from worlds to extensions accounts.
Yeah.
They don't really capture how we come to know these necessary truths about names. So that's led some people to explore different approaches to intentionality.
Like what kind of approaches?
Well, there's Church's view, which we talked about before, where senses are these fundamental things, not just derived from extensions across possible worlds. In that framework, Hesperus and Phosphorus could pick out the same thing rigidly, but still have different senses, explaining why we don't immediately know they're the same.
Different senses, same reference, classic Frege.
Right. And then you have more modern theories like Edward Zalta's theory of abstract objects.
Ah, Zalta. Another big name for philosophers.
Yeah, he's got this whole system where there are ordinary concrete objects and then abstract objects. And he distinguishes between an object exemplifying a property and encoding a property. Encoding is this special relation between abstract objects and properties. And his theory has all these tools for dealing with identity, existence, and the meaning of names. It's pretty complex, but powerful.
Sounds like we could do a whole deep dive just on Zalta. But for now, let's talk about one more approach to intentionality, the algorithmic view.
Ah, yes. That's Yanis Moshkavakis' baby. He says the sense of an expression isn't a function from possible worlds, it's an algorithm.
Algorithm as meaning. Now that's a radical thought.
It is. Instead of focusing on what a term refers to in different possible worlds, you focus on the procedure you use to figure out the reference.
Okay, give me an example. How does this work in practice?
Think about the statements, there are infinitely many primes, and there are infinitely many even numbers. Both,
True.
right?
Yep. Basic math.
But the proofs for those two statements are different. You use different methods to show they're true. For Moshkavakis, those different methods, those are the different senses.
So meaning isn't just about the truth value, it's about the process of getting to that truth value, kind of a dynamic view of meaning.
Exactly. And Moshkavakis developed a formal system called LPCR lower predicate calculus with reflection that lets you define these algorithms directly in the logic. It has this thing called a where clause, which lets you define relations recursively.
Recursively, like defining something in terms of itself.
Yeah, like you can define even x as not odd x, and then define odd x in terms of even predecessor x. And then you have base cases to get the whole thing started. The algorithm for figuring out if something's even unfolds from those definitions.
Okay, that makes sense. But what about algorithms that don't terminate? Like what if the process just goes on forever?
Ah, good point. Moshkavakis deals with that by using partial relations that might not be defined for all inputs. And he uses a three-valued logic where you can have true, false, or undefined. That way, if the algorithm doesn't give you an answer, the statement is just undefined.
So it's like the meaning is the algorithm and the denotation is the output of the algorithm if it produces one.
Exactly. And to compare senses, you look at the algorithms themselves. Moshkavakis has this whole framework called the formal language of recursion, where you can put recursive definitions into a normal form. If two algorithms have different normal forms, they have different senses.
So it's a way to tell if two meanings are the same by looking at the underlying procedures. Pretty neat, though I imagine these algorithms can get pretty complex.
Oh, they can. especially when you're dealing with quantifiers, which might involve searching through an infinite number of things, and the whole process of finding the denotation might take an infinite number of steps. But the point is, it gives you a really precise way to think about sense as a computational process.
This has been a whirlwind tour of intentional logic, from Frege's original insights to these really sophisticated formal systems. It's amazing to see how much progress has been made in understanding meaning and reference.
It really is. And for philosophers, this stuff is crucial for understanding all sorts of fundamental questions about knowledge, logic, language, and even reality itself.
So, to our listeners out there, think about how these different views of intentionality might apply to your own philosophical work. Where do meaning and reference come apart? What role do algorithms play in how we understand things? These are big questions, and the tools of intentional logic can help us tackle them in new and exciting ways. And we definitely encourage you to check out the work of the folks we've discussed, Frege, Carnap, Kripke, Mashavakis, and all the others. There's a whole world of fascinating ideas out there waiting to be explored. Thanks for joining us on the Deep Dive.